Okay, welcome to another Ginger Mathematician video where I'm going to finish off this paper and do questions 10, 11 and 12 with you and go through my walkthrough. Before I get started, do please like and subscribe if you're liking the iGCSE content. It lets me know that you want more of it and I will make more as well. So let's get started. So y is inversely proportional to the square root of x. I'm underlining the key information here. And then we're given some initial conditions, which we'll use later, and we want to find y in terms of x. So we're going to write down our proportionality statement. As soon as I see the word proportional, I think proportionality statement. And let's go through this carefully. So y is proportional to, or inversely proportional. So we're going to write 1 over, because it's inverse, and then the square root of x. So we're going to write the square root of x. This then gives me the equation, so we transfer this into an equation, and the way we do that is by putting a k for where 1 is, so we get k over root x. Check out my video on proportionality, that will go through this in much more detail. At this point we then substitute these numbers in, so when x is equal to 25, y is equal to 4. This reminds me the x goes here, and the y goes here, so we go 4 equals k over root 25, and we just take our time here, so 4 is equal to k over, well, the square root of 25 is equal to 5. If you're not sure in the exam, check on your calculator, it's the way to go. And at this point, well, we want to get k on its own, so what's the opposite of dividing by 5? We want to times by 5. On both sides, these cancel, and so we're left then with the answer of k equal to 20. Now that's not our final answer. Our final answer is when we put this k is 20 back in this original equation at the start. So our actual answer here, and I'll just remove some of the working so we can see it nice and clearly, is equal to, well, we know k is 20, so we put 20 back in here, and then over the square root of x for our 2 marks. Now what's typical here is that it gets you to substitute y to find x or substitute x to find y, and you can see both questions are here in B and C. So find y when x is 0.25, so when x is 0.25, y is equal to 20 divided by the square root of 0.25. And at this point, okay, that looks more like a 6 than a 5. Let me try and write that a bit more clearly as a 5. Just put this into your calculator, okay? You can use your GDC or otherwise. So 20 divided by the square root of 0.25, and that's equal to 40. Again, paper 4, use your calculator for straightforward calculations. Now this question works the other way round. So when y is equal to 5, so we put 5 equals 20 over root x. So we've got a slightly strange equation here, but we treat it in the same way. We want to remove the denominator, so I'm going to times root x on both sides. These cancel, so then I get 5 root x is equal to 20. I'm going to copy this across over here so I have a bit more space. Then we want to get the x on its own, so we divide by 5 on both sides. That gives us then root x is equal to 4. And at this point you can do this mentally, or then think to yourself, well, what's the opposite of square rooting? Well, that's squaring both sides. And that then gives us the answer of x is equal to 4 squared, which is 16. Which we pop in there. Again, at any of these points, you can use your calculator to help you work this out. All good. Now the last question here is a little bit sneaky. So this time they've introduced a new variable z. So z is proportional to y plus 2. But then they give you the initial conditions in terms of x and z. So I'll show you how we go about this kind of AA stars kind of question. Again, I write my proportionality statement. So z is proportional to, there's no inverse here, So it's going to be proportional to just y plus 2, which I'm going to put in brackets. That means that if we transfer this to an equation, this is where we have to be careful, then z is equal to some constant k, open brackets, y plus 2. Okay, brackets are really, really important here. Okay, this is why I put it in brackets here. Now, at this point, you think, well, we don't have an x to work out what k is. But we actually do, because if we go back to question A here, we have y equals 20 over root x. We already worked this out. So at this point, I can replace the y with 20 over root x. So I get z equals k 20 over root x plus 2. I'm just substituting answer in from part A. And now at this point, I can then actually work out my new constant k using the initial conditions. So when x is equal to 4, z is equal to 84, and then we just work through the algebra. So 84 is equal to k, open brackets, 20 over root 4 plus 2. So 84 is equal to k, open brackets, well, 20 divided by root 4, 20 divided by 2 is equal to 10. Then you can use your calculator at any point here. I'm going to transfer this upwards here. So we get 84 is equal to 12k, 10 plus 2 is 12. So then k, and you can do this on your calculator or mental methods, will give you 7. So our new constant k is 7. And so we want to copy across this equation that we made here, but replace the k here with 7. So we get z is equal to 7, open brackets, 20 over root x plus 2. Kind of sneaky proportion variation questions. So that's definitely a AA star part. It's quite unseen. It's not very, very standard by any means. Okay, answers on the board, so you can check through what I've done here and see where you get your method marks. And the examiner's report, A and B were very standard and was done correctly. Some people didn't do this last part correctly, which is slightly embarrassing, so make sure you've got the square root of x equals to 4, and you have to square both sides. But this part was pretty well done, considering it's not really a standard kind of question. So well done if you got question 10D correct. Okay, and on to question 11, a very typical extended functions question. So we're given two functions, two linear functions, 5 minus 3x and 2x plus 7. And our first thing is to solve f of x equals g of x. So what they want us to do here is take our f of x function, which is 5 minus 3x, and then make it equal to g of x, which is 2x plus 7. So this essentially turns into an equation solving problem. A couple of ways we can approach this. The way I tend to teach this in class, I add on the smallest amount of x, which is minus 3x. So what's the opposite of minus 3x? Well, that's plus 3x. And we do the same to both sides. This cancels with this, so we're left with 5. So we have 2x plus 3x is equal to 5x. Okay, and then at this point, right, we want to get the 5x on its own. So what's the opposite of plus 7? That's going to be minus 7 on both sides. This cancels, so we get 5x on its own, so what we wanted. 5 minus 7 is minus 2. Let me just write that up here. And then we want to, I can flip it across, that's fine as well, because it's an equation. And then I divide by 5 on both sides, giving myself the answer of x is equal to minus 2 over 5, which you may use a calculator as well and give yourself minus 0.4. Both is fine. I'm going to write in x is equal to minus 2/5. I generally write these things as a good habit as a fraction. Now we need to do a composite function. So as soon as you see these two next to each other, this is what's called a composite function, and we always work from right to left. So what we do is I'm going to write down g, and then I'm going to copy whatever f of x is into my brackets, which is 5 minus 3x. Okay, this is the way I like to think about it. And at this point, I look at my function 2x plus 7. So imagine I write 2x plus 7, like so. But what I do at this point is wherever I see an x in this function, I replace it, let me get the highlighter out, I replace it with 5 minus 3x. So I'm going to pop that, not with a highlighter, but with a pen, there we are. I'm going to pop 5 minus 3x where the x was. And at this point, this gives me an expression I just need to simplify. So we're going to use the hook to multiply the bracket. So we get 10 minus 6x plus 7. Again, if we simplify that down, well, 10 plus 7 is equal to 17. And the 6x stays as it is. So we get our answer of 17 minus 6x, final answer. And this one, they're trying to modify these questions slightly to make them slightly harder over the years, is now we need to work out f of x squared plus g of x squared and then simplifying the answer. So the way we do this is instead of having an x where we had in our linear functions, we replace that simply with an x squared. So wherever we see an x, we're going to replace with an x squared. So we get 5 minus 3x squared plus 2x squared plus 7. This is kind of a unstandard kind of function question. It's really trying to test your understanding that you're not doing f of x all squared. 7 plus 5 is equal to 12, so I'm collecting up the numbers. And minus 3x squared plus 2x squared is equal to minus 1x squared, which we generally write as that. So an interesting twist on the usual function questions you get at iGCSE. Okay, all good. And now at this point, what they do is they move the squared around. So they do find f of x plus g of x all squared and give them your answer as a standard quadratic. So what they want you to do is add the two functions together first. So we've got 5 minus 3x plus 2x plus 7. And then they want you to square it. So let's simplify what's in the bracket first. So 5 plus 7 is equal to 12. Minus 3x plus 2x is equal to minus x. And then they want you to square it from there. So once we've got that, then we can work this out. So remember, this is the same as multiplying 12 minus x times 12 minus x. It's a double bracket. And if we use FOIL on this, first outside, inside, last, 12 times 12 is 144. 12 times minus x is minus 12x. Minus x times 12 is minus 12x. Minus x times minus x is positive x squared, like so. And if we collect up the terms, we've got an x squared. That's all good. Minus 12x is equal to minus 24x. And then we've got a plus 144 at the end. And we've written it in the correct order. So x squared stuff first, then we've got the minus 24x, then the plus 144. Okay, and the function question keeps on going. So we need to now find the inverse. So as soon as you see minus 1 here, this means the inverse. So we're taking the inverse of this function here. So the way we do that, I'm going to copy it across like so, 5 minus 3x. The standard way I do this in my classes is we switch over the y's and the x's. So we get x equals 5 minus 3y. And at this point, we want to make y the subject. So we want to change it in such a way that we get y equals something. So the way that you can go about doing this, this is a minus, getting ahead of myself. So I'm just copying this across, is I'm going to add 3y on both sides. So I get it on the left-hand side. This cancels with this. So I get 3y plus x is equal to 5. And at this point, I then minus x from both sides. So I'm working slowly to get everything other than y on the right-hand side. So this cancels here. We get 3y is equal to 5 minus x. And then our final answer, is going to drop down very nicely. We're going to divide by 3 on both sides. This cancels with this. And we're going to write our answer as 5 minus x over 3, like so, and then leave it like this. The reason I switch at the start is that, say you forget to switch, then it's not a problem. You've still got the correct answer there without having to switch at the end. Okay, all good. And the last question is an algebraic fraction question. So we want to write a single fraction in its simplest form. So we need to write this in its simplest form. So let's copy across the functions. So we have 2 over 5 minus 3x. One of the key things here is to make sure you copy the question correctly. And we have 3 over 2x plus 7. This is a standard algebraic fraction simplifying question. The way we do this is, imagine these are in brackets. We want to find a common denominator. We do this by the process of cross multiplying. So we get 2 open brackets 2x plus 7. Notice we have a minus here. This is very important. 3, 5 minus 3x all over 5 minus 3x, 2x plus 7. Don't feel tempted here to expand the denominator. Leave it as it is. So in fact, that's going to stay the same in my answer. I know that's not going to change. And now we just need to simplify the numerator. So let's expand out the bracket using the hook twice. So 2 times 2x is equal to 4x. 2 times 7 is equal to 14. Now minus 3 times 5 is minus 15. This is where you have to be really careful, otherwise you can make an easy mistake here. Minus 3 times minus 3x is equal to plus 9x. We simplify this together. So we get 9x plus 4x is equal to 13x. That's those two done. 14 minus 15 is equal to minus 1. And we have our final answer. So you can just look through the mark scheme. So I put this into the PowerPoint. Again, please pause if you want to go through anything that I've gone through here. But you can see all the answers are here as shown. Generally, the first parts were done quite well. Interestingly, that question CI wasn't always done correctly, and they fell for the typical idea here of squaring the whole function and not just squaring the x. Inverse was done well. It's a standard kind of question, and most people knew how to deal with the algebraic fractions. So if you're looking for those higher grades, you need to be getting question 11 correct. Okay, and we're on to the very last question on this test, and it's a surprisingly straightforward question as well. So we're given two vectors here, so 3, 2 and 2 minus 1. Remember, with vectors, the top number represents left or right, and the bottom number represents up or down. And we need to draw and label these vectors on the grid. So the way I would do this is just work out each one first and then draw them on. So the vector 2a is just two lots of 3 and 2. So we just multiply both numbers by 2. So 3 times 2 is equal to 6, and then 2 times 2 is equal to 4. Now minus b, let me do that over here, a bit more space. All we do with minus b is we switch the signs. So we switch the 2 to a minus 2, and we switch the minus 1 to a positive 1. And for this one, this is kind of a combination question. So we're going to work out here 3, 2 minus 2 lots of this vector. Well, 2 times 2 is 4. 2 times minus 1 is minus 2. And then we just add the rows together. So 3 minus 4 is equal to minus 1. 2 minus minus 2, be very, very careful, and that's equal to 4. So at this point, we just have to draw the vectors on, which is great. So for this one here, this means essentially we're going to go 6 to the right, and we're going to go 4 upwards. So let's go here. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this here, in this direction, is going to be my vector 2a, so part 1. The vector here, minus 2, 1, well, this is going to mean 2 to the left and 1 up. So we can then take this vector here. So if we start here, for example, we go 1, 2 left and then 1 up. So I draw my vector in here. Arrows are important, you need direction. So this is equal to minus b, or part 2. And then the last one here is minus 1, 4. So let's start here, for example. Give yourself lots of room. This is going to mean 1 to the left and 4 up. So we go 1 to the left, and then 1, 2, 3, 4. So we're going to go all the way up here. Draw the arrow in. Write down that this is a minus 2b. And then I'd also write this is part 3. Just so you're very clear to the examiner exactly which vector is which. And do use a ruler in the exam. I do not have a ruler, but please use a ruler. Right, the very final question is we're given this kind of strange equation, and they've given you a hint here. We need to use simultaneous equations, find the value of P and the value of Q for 4 marks. So the first thing to do here is to actually multiply both these numbers by P and then both these numbers by Q. So what we're going to get is we're going to get 2P, because 2 times P is 2P, 3 times P is 3P, plus Q times minus 1 is minus Q, 4 times Q is 4Q, and that's equal to 10 minus 7. And notice that the row has to be equal to 10, and this row has to be equal to minus 7. So this is where we generate these simultaneous equations like so. 2p minus q is equal to 10, 3p plus 4q is equal to minus 7. And yeah, there's a couple of different ways we can approach solving this. What I would recommend, I'd label these 1 and 2. I'd multiply the top equation by 4. I'm going to write that underneath. But remember, when you multiply an equation by 4, you have to multiply everything. So 2p times 4 is equal to 8p, minus q times 4 is equal to minus 4q, 10 times 4 is equal to 40. And at this point, we want to eliminate the q's. We've got the q's the same, which is what we wanted. And the way that we do this is we actually add the equations together. Okay, and we just work through this really sensibly. If we find we should have minus, not plus, then by doing this check, you make sure you do eliminate what you want to eliminate. So 8p plus 3p is equal to 11p. 4q plus minus 4q. Well, a plus and a minus makes a minus. 4q minus 4q is equal to 0. It disappears. That's all very, very good. And then we get minus 7 plus 40. Check on your calculator if you're not sure. That's going to make 33. And if 11p is equal to 33, if we divide by 11 on both sides, this cancels here, we get p is equal to 3. That's our first answer. But we can't celebrate because we've got to work out what q is. So I'm going to sub p into my first equation. You can substitute into any equation, but I think this is the easiest. Well, if p is equal to 3, 2 times p is equal to 6. And I think at this point we can see q is going to be minus 4, but let's go through this. We'll do this steadily. Minus 6 from both sides. This cancels. We get minus q is equal to 4. So then q must be equal to minus 4. To get this, you just times by minus 1 on both sides is the correct operation to do. And then we get our answer of q equals minus 4, which is our answer. Quick look at the mark scheme. Nothing much to be shown here because I've already drawn them. And then the two answers at the end, which is p is 3 and q is minus 4. Quick look at the examiner's report. So many correct answers seen in the first two parts. And generally B was also done reasonably well as well. Feel free to read through and see what common mistakes could be made. Right, I finished another paper 4. It's always quite a long process. We got through this surprisingly quickly. I'll probably have a go at this at some point next year and do another paper 4 for the next iGCSE students to come along. Again, please share this channel with anyone looking to get that extra last bit of revision before their paper 4 exam, or just generally want to see what an iGCSE paper looks like and what is in store. All right, thank you for all your support. Again, I do appreciate every single comment that gets made down below in the comments, and I do try and reply to every single comment. So I'll try and do that with yourself as well if you write yourself a comment. Okay, bye-bye for now.